Okay, so our next question is Armstrong number. Now, what is an Armstrong number? So, Armstrong number is such a number which is equal to sum of cube of digits of a number. Okay, so to explain this, let me delete this title first. And let's say we have a number 153. Okay, so let's say we have a sum that is cube of 1 plus cube of 5 plus cube of 3 is exactly equal to the original number. Let's say we have original number n is exactly equal to the n. So basically, let's say 1 cube is 1, 5 cube is 125, 3 cube is 3 3 is 9 and 3 are 27. Okay, so basically we will have 5 plus 1 6, 6 plus 7 13, so 153. So this is the original number. Okay, so any number which is equal to sum of cube of digits of a number is an Armstrong number. Now, how can we calculate this? What we used to do, we used to reduce a number until it gets 0, and we used to take each digit. Let's say we have a number 153, right? So we used to take each digit using the modulo operator by 10 and divide operator by 10. So this will give you that is, let's say, number percent 10 and number divide 10. So this will give you 3 in this case, and rest of the number will be given by this 115. Okay, so 15 and 3, and this is how you can grab each digit of a number. Now you got the digit. What you need to do, you just need to do the cube of it in the case. Okay, so cube of it, let's say we got 3, then we did 3 cube. Okay, then we got 5, we did 5 cube, then we got 1, we did 1 cube. Let's add them together, we will get the number. Let's say any s in our case. So what we will do, we will check if our s is equal to the original number. Okay, we will get the palindrome. Armstrong. Okay, we will get Armstrong. I hope you got the logic. Let's try to write the pseudocode here. Okay, we have original number. Okay, so original number is n equal to 153. Okay, now what we will do, we will have the temp variable, because as I said, the number will be reduced to 0. Okay, and for after that we cannot use it. So temp will be n, and we will be using this for comparison perspective. Okay, now what we will do, we will have, let's say, sum equal to 0 for the first time. So sum will be sum of cubes of a digit of a number. Okay, what we will do, we will run a loop. So while our n is greater than 0, we will grab the digit. So how we can grab the digit? So digit will be equal to num percentile modulo 10. Okay, this will give you the digit, last digit of a number, basically a reminder. After that, what we can do, we can do sum equal to sum, the original sum, plus digit into digit. This will be square, and when we multiply it again with digit, it will give you the cube. Okay, and after that we can reduce the number again by the remaining number. Okay, n equal to n by 10, and after this our sum will be calculated. Now what we can do, we can simply compare if our temp variable, that is the original number, is equal to the calculated number. Okay, that is sum of cube of digits of a number, then we can simply write the number is Armstrong, right? And in the else, we can simply write number is not Armstrong. I hope you got the logic. Now, there is an additional use case for the previous question of Armstrong number, that is Armstrong number in a given range. I will delete this title first, and I have this function Armstrong. Okay, because in the previous timestamp we discussed about calculating the Armstrong number. Okay, so this is how you calculate the Armstrong number. So what I did, I actually created a function Armstrong. Okay, let me take the pointer. So I have taken this n as an input. After that, we have the similar functionality that we used to do in the Armstrong function. Okay, now here we need to return the number, that is return boolean, let's say true or false. Okay, here what we can do, we can return boolean, that is true, because if the temp, that is original number, is equal to the calculated number, we need to return true, and else we need to return false. Okay, now let's try to look at the pseudocode. I will just group them together. Okay, let's keep this aside. See what we can do. We have two numbers given. We have two numbers given, right? Starting number, let's say start equal to 10, and ending number, last number, okay, let's say 20. Okay, now what we need to do, we need to apply a loop starting from the 10 number up to this 20 number, and both this number are inclusive, right? That's why I have added equal to, less than equal to, okay, and I plus plus. So here we will get the individual number. After that, what we will check, if simple Armstrong number, we will call the function Armstrong number, and we will pass the number I as an input to the function. Okay, and this, if this is true, then we can simply say let's say cout, that is I is an Armstrong number, and after this we can simply say cout next line, and using this we can add a next line, and this is how you will get every number that is starting from 10 to 20. If any of the numbers are Armstrong number, then that will be listed one by one. So this is the pseudocode, and let's try to incorporate this into actual code. Okay, now let's code the Armstrong number problem. Now Armstrong number is basically a number where sum of cubes of digits of a number is equal to the original number. Then we can say that number is a Armstrong number. Okay, now I have defined two variables here, number for taking a user input, that is original number, and then I have cube of sum, which will store the cube of digits of a number. Okay, I have initialized it with 0, okay, for the first time. And here I will take a user input, and as the number will reduce because we will be taking each digit from a number, so it will be reduced to 0. But that's why we are storing a original number, that is reference of that number in the original variable, to check at last after the iterations are over. We will check if that original number here I have done here, if the cube of sum is equal to original, then we are printing Armstrong number. We will look into this. Okay, so here what I did, we did the same exact thing. We are grabbing the digits, and to calculate sum, that is cubes of a digit, and we will going to add it to the sum. So let's say I will delete this, do something here. I have written that. So cube of sum is plus equal to, okay, we can write using now digit into digit into digit. This is how you calculate the cube of a number, right? Digit is the current number that we have, and after that we will add a semicolon. And so okay, so after these iterations are over, we will get the respected result, that is cubes of digits of a number. So here we will check if that sum is equal to the original number we had, we can say the original number is an Armstrong number, and else it is not an Armstrong number. Okay, now let's try to execute this problem. I will create a new test case here. Let's say 153. 153 is an Armstrong number because 1 cube is 1, 5 cube is 125. So 126 and 3 cube is 27. So if you add 126 and 27, you will get 153. So if you run it, you will get 153 is an Armstrong number. Let's give 56. 56 is not an Armstrong number. Okay, so it's working perfectly. Now there is a use case for it, that is Armstrong number within a given range. So two numbers will be given to you, and you will need to check. So both numbers are inclusive. You will need to check each number whether that number is an Armstrong number or not. So here what I will do, I will copy this and comment it out. Oh my god, comment it out. Okay, so here after that I will just copy it, an Armstrong number within a given range. So the exact same thing that we did in the is prime function, something like that. So we will create a function boolean, and we will get is Armstrong. So basically whatever the numbers will be given to us, we will iterate over each number, and we will call this function by that number. So it will take a int n, which is the number that we have, and it will return true or false whether depending on the Armstrong number. Okay, so here I will use the same technique. Let's say we will be given two numbers here. So let me declare two variables, int a and b, and we will take this values from the user. Okay, like this. Okay, so here I will going to just iterate over all the numbers. So we will start from a, we will go up to the b number that we have, and it is inclusive. That's why I am adding I less than equal to b and doing I plus plus. So here I will just call the function. So if my is Armstrong function, and let me pass the number, that is I, and if it is true, this code will execute, this code block will execute, and I will print that the number, let's say I here in our case, is an Armstrong number. Okay, and in the else we don't need to print, we just need to print all the numbers that are Armstrong numbers. So here after the semicolon, before the semicolon, I will add end of line, so that each numbers will be printed line by line. Okay, cool. Now let's check it out. Let me give the same input 153. We need to give 2 inputs, right? So we will start from 2 and 10. So let's try to run it. So there are no Armstrong numbers. So we know that 153 is an Armstrong number. So what I will do, I will start from 150 and then I will go up to 155. Okay, so we will get at least one expected output. So 153 is an Armstrong number. Okay, so let's give something like 1 starting number and 1000, that is last number. Let's check from that perspective. So we will have 1 is an Armstrong number, 153, 370, 371, 407. Okay, we got all these Armstrong numbers. So I hope you understood this logic. Now it's your time to do the code. Thanks for watching.